For today's class, we're going over section 5.2. The problem we're doing is number 2, and then we're also going to do number 4. So let's get started. Number 2 says, use the charge field model to show that negative 2 times negative 3 equals 6. So we're just going to write this out so we kind of know what we're dealing with. So we have negative 2 times negative 3 equals 6. And it asks us to show with the model. So we know that we have to use 0 pairs. So that's why, because on a number line we start at 0. Everything has to start come together to equal 0. That's why when we're dealing with numbers, we do negative and a positive. So that represents 3 for one set. We don't need this. This is just a model. So this represents one set of 3, and then we want to do another one because it's 2 sets. And now let's think about the problem. So the question actually says negative 2 times negative 6. So since the first number is a negative, that is telling us to remove. And since the second number is negative 3, we are going to be removing the 2 sets of negative 3. So we're going to circle the 2 sets of negative 3, and those are actually going to be coming out of our diagram. So then we now know that, so now since we took out the 2 sets of negative 3, what are we left with? Now we can count and we see that once the negatives are out, we have 6 positives left. So that is why we come up with negative 2 times negative 3 equals 6, because when the negatives are gone, we are left with the 6 positives. So let's kind of recap how we did this. We used the problem to look at the signs in front of the 2 numbers. So with the negative, it meant remove, and then the second negative, we're removing the negative numbers. So that was problem number 2. Now let's take a look at number 4. This says, in each of the following charge field models, the encircled charges are removed. Write the corresponding integer multiplication problem with its solution based on the model. So the first one that we're going to look at is part A. And I'll just kind of draw the diagram on the board so we know what we're looking at. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3. And then we have the negatives circled in groups of 3. And then all of the negatives are circled, and they are being removed out of the set. So now let's kind of look at how we did the last problem also. So let's start with what we know. We know that we obviously have 2 sets of 3 because we have 3 negatives circled twice. So we're not sure what the signs are going to be yet, but we have a 2 and a 3. So the first number has to be negative because we are removing out of the group. So we know that the 2 sets have to be negative since they're going out. And then so then each have 3 negatives. So therefore, this number has to be negative because the negative numbers are the ones being circled. And then once again, we are left with 6 positives. So that's what we get from this model when we have 2 sets of 3 negatives being removed from the problem. Now let's look at part B. In our diagram, we have 4 sets this time. So 1, 2, 3, 4. We have 4 sets of 2 with the negatives as well. So altogether we have 16 on the table, but that's just including 8. So we have 4 sets of 2, and we don't know what they're going to be yet. And then in this problem we have all of the positives circled. And the positives are going to all be removed from the group. So just how we had an arrow drawing out being removed, we have the arrow again, but this time with the positives being circled. So we are removing 4 groups, as we said, because we know that they're going out of the problem. And then now let's look at what we are actually removing. So if we have 4 groups, since the circles are separate, we have 2 in each group. So now we have 4 groups of 2, and since they're going out, that's why the 4 has to be negative. But then let's look at the 2. So let's see what we have first. So if we know that we have 8 negatives left, because once we remove all the positives from the problem, we have 8 negatives left in our charged field. So we know that we're going to have to end up with 8, or negative 8, since there's negative 8 left. So therefore, in order to get the negative from the negative 4, we know that our 2, therefore, has to be positive. So that is how we use charged field models for these problems.